Hi everyone. I wanted to go over a couple of the word problems in the implicit packet with you. Most of the problems are pretty straightforward and I'll be posting the key, but these two take a little bit more thinking, and so I wanted to make sure we talk them through. Okay, so slope of the line, tangent of the curve. Hopefully we're all keyed in to when we're looking at a problem in calculus and they start talking about the slope of the tangent line, that they're asking for the derivative. So they want the derivative of x plus xy plus 2y squared equals 6 when y is 1. Now, we'll get to this part in a minute. Let's talk about the derivative part. It's a curve. We can't isolate y. However, we want the derivative of y with respect to x. So we're going to have to use implicit. Remember, that's not something that's going to be told to you. You have to recognize the style of problem where it's an implicit problem. Being asked to find a derivative of something that's not in function form or not a y equals form is a good clue. So here goes my derivative. 1 plus this little piece, I need to use product rule. So y times 1 plus x times dy dx. The second function was y, my first function was x. So y times derivative of x plus x times derivative of y plus 4y dy dx equals, and I don't know why we forget this all the time. When we take the derivative of a constant at 0, people forget that in implicit problems like so often. Maybe just because you're so happy that you're almost done with the implicit, you're like, oh my god, I'm almost done. And then 6, you kind of go mental. Okay, I'm gonna rearrange my terms. I'm gonna do my factoring, and hopefully you're pretty comfortable with that. I'm gonna go to a dual screen here so we can look. So where I have 1 plus y plus x dy dx plus 4 dy dx equals 0. That means I'm going to have dy dx equals -1 minus y divided by, did I forget something? Oh, I left the y off of this guy. Yeah, I'll say something's missing. 4y dy dx. So divided by x plus 4y. Okay. Hopefully you're fine with the algebra, moving the terms, factoring out, and so on. So when y equals 1, that gives me -2 over x plus 4, which is not any of my answers. My answers clearly, when I go back to just that page, clearly they've plugged an x and a y in. I need the x when y is 1. And you're going to get that from the original curve. So the original curve is x plus xy plus 2y squared equals 6. That means when y is 1, it's going to look something like this. X plus 2 equals 6. So 2x equals 4, x equals 2. When y equals 1 on this curve, x has to be 2. So then that makes that 2. That x is 2. 2 times 1 is 4, is 2, 2, 4. That makes that equal to 6. So then we're like, okay, if x is 2, this is negative 2 over 6, negative 1/3. Hopefully that's a choice. And it is, because it's always C, right? We just pick C, we're good. Okay. So a couple things on this problem. The wording. Slope of the line tangent to the curve. We're dead in the water if we don't know what that means. Second thing, we have to know that we've got to use implicit. Otherwise, we're going to be stuck in how to write this derivative. And then the third thing is I need to know how to get the x from the x from that goes with the y, and that's about going back to the original curve. Implicit questions seem to have that in common often, at least the ones on the AP exam, is that somehow you end up working your way back to the original curve. Now, this question. Equation of the tangent line to the following curve, it should just be singular, at the indicated point. So in this case, we have the x and the y, so it's a little easier. We have to remember that we need the equation of the tangent line. So to get the slope of the tangent line, we'll need the derivative and you're going to need to use product rule and implicit to get this one to work. That's all I'm going to tell you on that one. This will be written out on the key, so I think you'll be able to see it, and this should give you enough of, if we start looking at how I've writing my derivative, that I'm going to use a product rule here. Okay. Not the only way to do that. There's a couple different options, but you could, I guess, if you wanted to, you could rewrite this as cosine of y equals 1 over x, or x to the negative 1, and then take your derivative. We don't know how to do anything with an arc cosine derivative yet, so I don't think we're not going to undo the cosine, but if I took the derivative here, this could avoid the product rule. Ooh, I just thinking about this in a different way. Yeah, let me kind of explore this. So the derivative of cosine is negative sine, sine, cosine, negative cosine, sine. So negative sine y dy dx equals negative x to the negative 2. So dy dx equals negative x to the negative 2 divided by negative sine y. Wow, that couldn't be uglier. How about 1 over x squared sine y? Now I just want to try something for a minute. So one thing, so what we did here, even though in the 3 seconds ago, I'm like, I'm going to use product rule. Then I thought about it, I was like, well, let me just write this a different way, and then I don't have to use product rule. Let's see if I use product rule, instead of rewriting it, what happens. Let me get my pages organized. I would like a blank page right there next to this guy. So let me see something. We got 1 over x squared sine y. Let me think about this. If I did x cosine y equals 1 and I use product rule, I would have cosine y times 1 plus x times negative sine y dy dx equals 0. Because this would be like my g and that would be my f. So there's the second function, derivative of the first, derivative of the second with the implicit tag. So negative x sine y dy dx equals negative cosine y. So dy dx would equal negative cosine y over negative x sine y. So that would be cosine y over x sine y. Now, what I'm interested in is, are those really equivalent to each other? Are they really equivalent to each other? Bet they are. Let's look. Remember, this would just be our slope. All right, so let's go to this side. X is 2, y is pi over 3. So this would be 1 over 4 times, let's see, sine of 60. That's the big sine, so root 3 over 2. So 1 over 2 root 3. Okay. Over here, x is 2 and y is pi over 3. So this would be cosine of pi over 3. So cosine of 60 is a half. And then this is 2. And then this is root 3 over 2. Those divide. So I have 1/2 over root 3, which is 1 over 2. Oh, they're the same. Oh, sweet. So, what did we just do? I just showed more than one way to do this derivative. In both cases, you had to use implicit. In one technique, I rewrote the derivative just so I didn't have a product anymore, and then I just did my implicit. The other one, I left it as it was originally and hit it with a product rule. I think the other way was actually the splitting it up a little bit was prettier. As long as you're not violating any algebra, rewriting the derivative, the original function in a slightly different way, and then taking your derivative is not a problem. This would be your slope, whichever way we got it, of our tangent line. So if we just want to finish this problem, why not? How about y minus pi over 3 equals 1 over 2 root 3 x minus 2. There's your line. It's not beautiful, but there it is. Happy implicit, everybody.